My project is going to be about RF/RC cars. Um, stands for radio frequency remote control cars, and they are made out of a power supply, a controller with joysticks or buttons, a frame, the motors, and more importantly, the transmitter on the controller and the receiver on the car. The trans data transmission process involves taking each and every input, giving it to an encoder, which makes it into binary information, and then giving it to the RF transmitter module, which consists of an oscillator, which makes the a general sine wave, um, and that is called a carrier wave. The modulator adds imperfections, which is the actual data storage component, either through changing the amplitude or imperfections with the amplitude or with the frequency. The amplifier strengthens that whole signal, and then the antenna actually takes that signal and turns it into a radio wave. With AM going longer distances and it can go through obstacles because of the low frequency. This radio wave is then taken to the receiver, which is made out of an antenna, which takes all frequencies and turns it back to a sine wave, an amplifier to make it strong enough to use. A tuner filters out all of the frequencies except the one you want. Um, it basically acts as a bandpass filter, and on car radios and walkie-talkies, that's known as channels, a specific frequency. And then a detector, which takes that um, sort of specific sine wave, electrical sine wave, and converts it back to binary. And then that binary is sent to a microcontroller, and then to the motor drive electronic speed controllers, and then finally to the power supply to give to the motors for the car to move a certain way or to perform a certain action. How this ties in with electrical engineering is that you have to pick either AM or FM for the specific application. You have to calculate the amount of power to give a certain amount of torque on the wheels. You have to choose a specific frequency so you don't clash with regulations and to minimize noise. And you can actively choose different electronic components than the ones mentioned here if you need them in your application. The component I chose is a detector demodulator, and they both take data from the incoming wave or sine wave. There's three types: AM, FM, and power detectors. Of AM, because of the long range going through obstacles in RC cars, you have envelope detectors, product detectors, and digital demodulators. Um, Envelope detectors use rectification to make a proportional voltage. A product detector multiplies the incoming IF wave with a locally made copy of the carrier wave, and that makes a sum frequency, which is thrown out, and a difference frequency, which is proportional to the IF wave at baseband. And a digital demodulator uses envelope detection with a full wave rectification, and it takes the absolute values of the outputs of an ADC, which is not what we're focusing on here. We're focusing on the envelope detector. If you look at the top right diagram here, you'll see the AM envelope detector. It uses a transformer to give a frequency specific input, an ideal diode and an RC circuit to actually detect the data. Um, the capacitor remains charged at the maximum input voltage, as seen in this other diagram, while the resistor gives a discharge path that follows the actual changing amplitude of the voltage, which has the actual data encoded. The idea of transformers, bandpass filters, and modifying RC constants to get this data is more or less exactly what we've learned, and it is analyzed using the simplified diagram in the bottom right. These are my references for info and images, for the overall process information, and info in those last three diagrams. And that should be everything. Oh, oh no. Oh.